Queste erano le comunicazioni che vi dovevo. Abbiamo adesso una presentazione di soci che attendiamo con molta passione di Thibault Damour ed è Physics and Reality, Philosophical Implications of Modern Physics. Ti prego.
Grazie Presidente. Mi dispiace di non poter parlare italiano, ho bisogno di parlare in inglese. Yes. So, physics and reality, the philosophical implication of modern physics. There have been 3 revolutions of fundamental physics in the 20th century. La relatività speciale, la relatività generale e la meccanica quantistica. I've indicated here just a few of the people who have been leading contributors. As you will see, Einstein contributed in an essential way to special relativity, to general relativity, and to quantum theory. For quantum theory, others have been very important. These 3 revolutions, they underline our current knowledge of modern physics, including particle physics, cosmology. This is the Virgo detector of gravitational waves, the French-Italian gravitational wave detector, black holes, binary pulsars, but also everyday technology. Okay? In particular, when you use your car and use GPS, you should know that this uses in the software essentially special relativity and general relativity. Otherwise, you would hit the wall in 1 minute 30. When you use a smartphone, you have to know that this is a condense of quantum mechanics, actually, which allows this to work. But beyond the usual view of science and in agreement with the main purpose of this beautiful IstitutoVeneto, as Schrödinger said, what is the value of natural science? It is not just the isolated knowledge obtained by a group of specialists, but it has meaning only if it contributes to the synthesis and towards answering the synthesis of culture and to answering the basic demand of the Delphic deity, Newti Theoton, okay, conosci te stesso, or to use the words of Plotinus, and we, who are we anyhow? So the aim of this conference will be not to say a few technical things about modern physics, but at the philosophical level, say what is the message for all of us? At least let's start thinking about it. And I will talk about 2 specific aspects of which have, in my mind, some philosophical implication of modern physics. The concept of il blocco spazio-temporale, the fact that in relativity, space and time are united, but not just at a mathematical level, but we have to think philosophically what means spazio-tempo, and the mysterious concept of superposition of classical realities, which is essential part of quantum mechanics. Concerning relativity, let me first start by discussing what happened when Einstein arrived in Paris in 1922. What is interesting is that all the newspapers, the usual daily newspapers in Paris, wrote articles with titles such that, you know, in French, le temps n'est qu'un songe, il tempo è solo un sogno, il tempo è una illusione, il tempo non c'è più. And there were even cartoons here, il tempo non esiste, dice Einstein. Here the joke is that in French, you know, tempo means both the weather and the tempo. So it was raining at the time. And here there is also a dinosaur, plesiosaur, coming back and saying, did you say, Mr. Einstein, that time did not exist? What is interesting is, although Einstein discussed with physicists and mathematicians, empiricists, most of them never concluded that time did. I mean, they did not take seriously what relativity was saying about time. Only, in a sense, journalists understood there was something going on for everybody, and as we will discuss also on the following slide, some artists. Okay, but before this, let me try to convey the basic idea of questa nozione di blocco spazio-temporale, so, che è dovuto non soltanto di Einstein, ma anche di Poincaré e di Minkowski. So the usual view of separate space and time is that that objects, like these are billiard balls, if you play billiard on a billiard table, a red ball and a blue ball, they move in a certain space, and at each moment of time they move a little bit. You see, they move, they collide, and they go. And reality is conceived as two separate notions, space and time, and there are things existing in space and they evolve in time. But these are separate things, okay? Reality, for instance, is only at one moment of time. But spazio-tempo means that you put together as if there were things, you know, that you would, cards, playing, and you put them together, you stack them together, and then you have one block in which the story of the red ball becomes a line, the story of the blue ball becomes a line, and you take away the notion that there was a slicing, that there was time. So this is really la scomparsa del presente, so we have to take this idea seriously. Newton, the previous concept of time, as mathematized by Newton, was compatible with the idea that there was still time, okay? Because in Newton's view, there were things evolving in time, and the usual notion of time is that reality is only the present moment, il presente, and that the past does not exist anymore, has existed but is not real anymore, and the future does not exist at all, will exist maybe, but it is really hyphenated, you see, just vague thing, while in Einstein mathematical representation of space-time, you have only one block, and the past and the future coexist, and actually the only thing to exist. The present does not exist. There is nothing real in relativity saying the now exists, okay? And this is made violently clear by what now is called il paradosso dei gemelli, which was first presented at the Quattro Congresso Internazionale di Filosofia in Bologna in 1911. There were 400 people attending this conference, mathematicians, physicists, philosophers. Federico Henriquez was the president of this conference and talked about il problema della realtà. Henry Bergson, Henri Poincaré were there, and Paul Langevin, a physicist and a friend of Einstein, presented the concept of space-time, and with this idea of the traveling twins, gemelli. So what is this? This is that on Earth, for instance, you have two twins, due gemelli. So they start with the same age, Then one of them goes in a rocket, and let's say either this rocket goes very far and then comes back, or simply goes around the Earth, turning around very fast, close to the velocity of light. And when the twin which has traveled comes back on Earth, then he's still young compared to his brother who is, let's say, very old, okay, if you push things. But this means, really, when you think about it, that in, let's say, 1 minute of your time, you can see what Earth will be in 60 million years. You can jump, you will be just 1 minute older than now, and you come back here at IstitutoVeneto, and you see if Venice has survived 60 million years, and yes, from the hydrological point of view, yes, there are reasons to doubt it. But think about the violence of what it means. It means the future, which is usually conceived, as not existing. What will be the Earth in 60 million years is not real, but you can live it in 1 second of your time. Okay? So it's a violent thing. But most people, so it's a viaggio quasi istantaneo nel futuro, okay? And the violence of this is usually not fully grasped. But, which means that at the time, most mathematicians, physicists did not understand that this was something philosophically violent, but some artists did. Like, for instance, Marcel Proust was aware that the ideas of Einstein on time were linked to his own idea of time. He wrote it explicitly. And most importantly, actually, Proust followed the visit of Einstein. This was the last year of his life. And in the spring, when Einstein came, one day he called his assistant and he said, now I can die because during the night I have written the end. I have written the last sentence of my book, okay? And this last sentence is here in Italiano, so that you can see. And he's putting an image of come se gli uomini fossero appogliati su vivi trampoli. So it's the image of the trampoli. And then, which describes the homini come giganti immersi negli anni, epoche da loro vissute così distante l'una dall'altra, tra le quali tanti giorni sono venuti a interporsi nel tempo. And when you think about what he's saying, he is describing a space-time picture of man just being stacked like this in the years vertically, okay? But he wrote other sentences that he felt. He did not understand the mathematics of Einstein, but he felt that was interesting from the artistic point of view, okay? And around the same time, Dali also commented this famous, montre molle, or la persistence of memory, as saying, this is le camembert del tempo e dello spazio, if you know what is the camembert, this soft French cheese. So anyway, at the time, journalists and artists understood that there was some interesting, philosophical violence in the concept of modern physics, while most people said, okay, it's just equations, let's not worry, is it true or not? Now, going to quantum physics, I will use the fact that I was fortunate to collaborate with a young Belgian rover, and we wrote Fumetto, which is translated in Italian, on quantum mechanics. So if you want to understand better quantum mechanics, I would advise that maybe you can have a look at this. So we all know that one of the fundamental equations of the physics of 20th century is Einstein's E equal mc square, che l'energia è la massa moltiplicata della velocità della luce al quadrato. But actually, it's less important than another equation, which was first written down, but in an unclear way by Planck, and then Einstein understood the basic meaning of this equation, which is che E equal HF, energia is uguale alla frequenza, una frequenza, moltiplicata della constanta di Planck. And it took many years to understand the real meaning of this equation. Why can you associate to any energy a frequency? The frequency of what? Actually, the real frequency, I mean, Einstein understood this with the photon, okay? De Broglie understood this with particles, but the real fundamental meaning was understood by Schrödinger in 1926, where putting together, you know, parto dall'equazione di Planck-Einstein, and he wrote this equation, which remains the fundamental equation of quantum mechanics, which is called l'equazione di Schrödinger, which means what? Which means that there is a mysterious object called the wave function, psi, which evolves in time by the energy. This is the energy operator, l'Hamiltoniana, and this is time evolution. So what is, and even today, for many people, the physical and philosophical meaning of this equation and the wave function remains mysterious and strange. And I want to insist on what is the fundamental, the analog of the paradosso dei gemelli. This is il gatto di Schrödinger, which is here. So what is the gatto di Schrödinger, which actually was invented by Einstein, okay? In discussion with Schrödinger. This is the following idea. In quantum mechanics, if you put a cat in a box and a closed box, and in the same box, so at the beginning there is one usual cat alive, and then you put a device which contains an atom which can decay, okay, or not, with some probability in the usual way of thinking that the decay of an atomic decay is random, such that after 1 minute, either the atom has decayed or not. And if it has decayed, it triggers a mechanism which goes from the microscopic to the macroscopic world, and then diffuses poison in the box, and then kills the cat. Which means that after 1 minute, according to this mathematical equation, you have a function which describes the reality of the cat, and this function, after 1 minute, is a superposition, is made of two parts, and in one part, the cat is alive, in the other, it is dead. Okay. What does it mean? Each time we look at a cat, it is either dead or alive. You know, it's never a superposition. So this is the paradox. What does it mean? For the usual interpretation of quantum mechanics was introduced by Max Born by saying, okay, we don't understand why, but let's impose the idea that indeed the cat is either alive or dead, and the wave function gives the probability of this, the cat being dead or being alive, okay? And Einstein did not like so much because he said, it's fine, probabilities. I introduced them in quantum mechanics because he introduced quantum probabilities, okay? But you have to explain where they come from, the problem. Who is setting the dice, okay? Then other people like Niels Bohr said that penso che non ci sia una realitica quantistica oggettiva, saying, no, you have to forget the concept, there is no reality, just observations, you know? But still, Einstein was never happy with that, and the last conference he gave in April 1954 in Princeton, he talked about, actually he said the following thing. He said that according to the usual interpretation of quantum mechanics, l'onda di Schrödinger dà una descrizione completamente sfocata, which is represented by this Van Gogh type superposition of things, you know, sfocata degli oggetti del mondo macroscopico, a meno che qualcuno, ad esempio un topo, So for Einstein, somebody could be evidently a mouse. Non stia a guardarli. And then he asked the question, is it possible that the gaze, lo sguardo di un topolino possa cambiare considerevolmente l'universo? Just as a question, is it credible that just the look of a topolino sull'universo can change the universe drastically from one state to another, you know, from a fuzzy state to... And a young man attended Einstein's last conference, and the fact that Einstein asked this question that gave him the courage to give answer. This young man was Hugh Everett, and so the main point is, and this is a philosophical point, is the idea of Everett was to take seriously the mathematical formalism that quantum mechanics gives us of reality, and saying, let's consider that we have to adapt our notion of reality to what the formalism says, instead of trying to, you know, placate our usual notion of reality and say, it's strange, why, what's going on? To say, no, I have to change my own idea of reality. And the wave function is a complex function which represents superposition of classical realities. Like, for instance, maybe this morning Franco hesitated in taking, you know, a tie which would be red or blue or black, and today he has chosen this thing. But in the full universe, there is a superposition of two of these rooms where Franco has a red and a blue one, and maybe I have taken a red one. Okay, that like waves, because you know waves, these are small ripples. Ripples on a lake, they superpose. You have this wave and then these waves, and they add mathematically, and there is nothing wrong for waves to be in a superposition. Okay? And the basic idea of Everett looks trivial, says nothing, saying, he was saying, so it's written in Italian, so you see, contrariamente a Schrödinger, io accetto il fatto che il mondo quantistico sia fatto realmente di tali sovrapposizioni di configurazioni diverse. You accept the fact that reality is a superposition, and but then you have to explain why when you look at a cat, you see it either, and that's the new idea, either you see it dead or alive, okay? Because you say, no, I only see, so it cannot be a superposition. And so it's the next step in his idea, and this next step, one way to make it more understandable is to take what is used in cinemas, in movies. You know, in movies, there is the idea, I'm not sure of the best Italian word, sovrimpressione cinematografica, in French, surimpression, where you can, on the same pellicola of the movie, you can superpose, overprint several images, like two movies, okay? But then the idea is when you superpose two movies, these are two different stories, and the people in these two stories, they don't know that the other print exists. They live their own story, and then they live superimposed, but they are not aware of what is going on. Okay, now, and technically, what Everett said, for instance, was when there is il gatto di Schrödinger, so you have mathematically, and by the way, the Fumetto uses the fact that the wave function is a complex number. A complex number can be described by a vector in the complex plane. A vector in the complex plane is described by an amplitude and an angle, and then you can make a convention that the angle is a color, like blue is a certain color and red is another color. Colors are on a circle, okay, circle of colors. and therefore they represent an angle. Okay, so that's why the fumetto uses color only after a certain moment, because when the objects become quantum, they become superposed. And when they become superposed, you can draw them in superposition, but with different colors, so that you know, like here, you know that they belong to different parts of reality. But the basic idea of Everett is not that the cat is a superposition, but when there is an observer who looks at the cat, this observer is in a superposition, and the observer that sees the cat alive and the one that sees the cat dead, they are in superposition, but each part, like in a movie, they are not aware of the other thing. So, and he tried to give arguments of why they are decorrelated. In mathematical terms, it means because waves which have different frequencies are orthogonal with respect to the scalar product of wave functions, okay? So he had in mind some technical aspects, but in my mind, the main point was this intellectual courage of saying, okay, let's take seriously what physics is telling us about reality, and this idea actually has consequences that you observe today, because people in the 80s, when they tried to describe what was the quantum description of cosmology and how galaxies are formed, so now we are talking about not only, you know, the Earth, but even the full galaxy, they came out of quantum fluctuations, which means that they started like the Schrödinger's cat as quantum events, which were elevated to the classical level. And because of this, they could technically compute, actually, what is the level of fluctuations coming out of inflation, okay? And these predictions have been verified experimentally. Therefore, today, it is considered as very probable that indeed, even the biggest objects in the universe, galaxies, they are in superpositions because they came from quantum events. So that the reality at the largest level is, in fact, must be thought as being in superposition, okay? This quantum cosmos. To end, and this is my last slide, I want to finish by this summary, which is the philosophical summary, by two sentences. First by Einstein, saying, as you can see, la vera difficoltà sta nel fatto che la fisica è una sorta di metafisica. La fisica descrive la realtà, but we know only what is la realtà, la conosciamo solo attraverso la descrizione data dalla fisica. So, so what means finally reality if you need the formalism? So what Einstein was saying is, first you need, reality is defined actually by the mathematical formalism that describes reality. So you have to adapt your notion of reality to the equations. And actually, this is, in my opinion, in full agreement with the basic idea of the philosopher Immanuel Kant, who wrote in the Critica della ragione pura that, okay, up to now, you have the text in Italian here, we have admitted that all our knowledge must be based on the objects. So the idea is that there are real objects that exist, like the sound of a smartphone, and then the objects exist, and then physics is to be adapted to understand what is these objects. Okay, but he said at the end, he did, and this is the Kantian reversal of things. Chiediamoci dunque una volta se non ci troveremo più contenti nei problemi della metafisica, supponendo che gli oggetti siano regolati dalla nostra conoscenza, which means the inverse, saying it is the objects which have to be actually adapted to our knowledge, okay? Which is this idea that reality is actually made essentially is of categories which the human mind imposes on the universe. And this is, in my mind, a way to say that we should take seriously the strange image of reality which has been given by modern physics, by, let's say, the mathematical formalism of modern physics, space-time and quantum superposition, and say, okay, this is reality, this is the best description we have, so now let's take seriously this and adapt our knowledge of reality to this, okay? So we have to change our concept of reality according to this, which is, to me, a central message, philosophical message of modern physics. Okay, thank you for your attention.